Yay.
Well, the only time I ever do this is when someone's absent and they want it. Share screen. I did during COVID, so I have many of them, and not all of them. All right, make sure it pass left. That is not your calendar. That is your calendar. No, even that's not right. Hey, 8.2, it's a Friday. I can't ever do this class. So, the law of science. I'm never able to get this done on a Friday, so I'm just gonna bite the bullet and make this into 2 days. So you do have homework tonight and all that jazz. It's gonna be in front of you here in a second, but I'm saying this was the normal plan, but then I was like, crap, I'm doing law of science on a Friday, and I know I can't get it done in 41 minutes or whatever it is. All right, so here's your homework. It's gonna be technically 2/3 of the entire homework assignment, but it's really just half. It's one concept. It comes in 2 different flavors, but it's one concept. There's more. You need to learn some PreCalc? Oh, that's.
But it said 2,468 quantities. I paused it at 61. I don't know what.
What?
Yeah.
I hit 24.
It was.
I was late to class and I hit what on it?
2,468.
Oh, I might hear from that.
But it only got to 61, so I'm gonna delete the job.
Thank you.
Okay.
Thank you.
I saw that. I was like,
But it stopped.
You're the
it
reason.
was the paper jam.
Oh, thank God.
I fixed the paper
Oh, thank God.
I fixed the paper jam.
All right. Wow.
That didn't work going on.
Yeah, but I was standing right there and there's the principal, right? Well, you've got, remember, so calculator's not your friend, so you can fat finger things as well too. All right. That'll also explain why this is a bit thicker than normal. I only have 24 pre-calc students in one. I was like, okay, I guess that's how thick it is. I didn't pay any attention. Luckily, it jammed. Well, 60-ish. All right, who, and I asked you this yesterday, and none of you said you did, except even the person who did it 4 months ago, can't remember it. Who remembers law of science? You even remembered there was such a thing called law of science.
It's like sine A over A.
Thank God, nobody remembered it.
I don't remember what they were, but I know they exist.
The answer was 15.9. I got like 16.
No, I just saw it.
So wrong. Should, I mean, within a tenth or something is fine, but not that far off. All right. So for Elena, who actually remembers doing it, law of science, I remember learning this many times. I probably took 3 math courses, 1 in high school and 2 in college, where we did law of science. And all 3 times, the teacher and the professor gets up, he law of science, and everybody in class goes, this is easy, it's so easy. Because they choose not to teach the whole darn thing. There's a horrible one of these, and there's 2 easy ones. And so the lazy math teachers teaches you the 2 easy ones. You get this impression that, oh, I love law of science. And law of science is the visibly looking the easy one. The law of cosine gets no love because compared to law of sines looks really easy. And when it works, it's super easy. So nobody ever wants to use law of cosines. Well, it turns out that the one flavor of this that doesn't work very well causes lots of problems and triple the work. You never want to do law of cosines. You only ever want to do law of you never want to do law of sines. You always want to do law of cosines because law of cosines is the one that's always easy. This is the one that half the time it's hard and half the time it's easy. If you get a crummy math teacher, they're never even going to show you the crummy one. Okay. All right. Off my soapbox. So let's see. We've been dealing with this chapter so far. Right triangles, right? And we have 2 ways of solving for angles and sides of right triangles. The Pythagorean theorem only solves for sides, but then we got the basic trig functions, and that will solve for angles and sides, right? The but here obviously is what if it's not a right triangle, right? So if it's not a right triangle, meaning it's either acute or obtuse, okay, PreCalc and higher gives these a fancier name than acute or obtuse or non-right triangles, and they call them oblique triangles. Okay, I'm not having you write it down because I never heard this word before I opened this book. I've never heard them call oblique triangles, but apparently you can call non-right triangles oblique triangles. Great. Okay, so today's class is how do you solve for the sides and for the angles of oblique triangles, right? We will do this with two formulas. One is called the law of sines, and one's called the law of cosines, right? And of the two, the law of sines is the beautiful one. It's the beauty queen. She gets all the attention, and everybody looks at the law of cosines. Ooh, get that thing away from me. It turns out the law of cosines is the better one to use because there's no problems ever with the law of cosines. All right, so we're gonna get two new trig identities, law of sines, law of cosines. Technically, you've already seen these two, okay? It'll take us 2 days to get through law of sines and in 1 day do law of cosines. Law of cosines is ridiculously straightforward. It's algebraically more complicated than this one, but it never causes you problems. Here's problem number one. The law of sines and the law of cosines is written with this triangle in mind, where all the sides are called A, B, and C, and all the angles are called. And then as soon as I start throwing other letters, then wheels fall off. So it doesn't have to be triangle ABC. It could be any triangle, but they're going to give it to you in the form of ABC. Okay. This is a proof. Take step number one. It's either going to be an acute triangle or it's going to be obtuse one. I'll only do the proof for the acute. You can read the obtuse all by yourself. From any one of the vertices, drop a altitude. Remember, an altitude is a line that goes from the vertex of a triangle perpendicularly to the other side. Cool, altitude. We also call altitudes heights, right? So that's why it's H. Okay, cool. Tell me something about angle C with your vast knowledge of trig. Tell me something about angle C. Well, it looks like, and plus it's a acute triangle, it's got to be acute, right? Tell me something, you got a lot of knowledge of trig. Tell me something about angle C. What's it equal to? I've already given you the hints. Using your vast knowledge of trig, how big is angle C? Calculate it.
I don't know.
Well, how do you calculate angles in trig?
Inverse of one of the things.
So which thingy?
But
Well, what did I give you for information?
See?
each
Keep
side-
talking.
Each side and each angle.
I didn't tell you how big this piece is. I didn't tell you how big this
Oh,
piece
but
is.
you made two, right?
Okay, so tell me with your vast knowledge of trig, how big is angle C?
60 degrees.
You're guessing now. We have 6 trig functions, and they all will tell us the angles.
Okay, sine of H over N.
Sine of H over A, that's how big angle C is, right? So the sine of C is, it's not complicated. It's, the only thing I gave you was the opposite and the adjacent for that triangle, right? Okay, cool. Yay. Suspiciously, I'm going to solve for no, H. So solve for H.
A sine C.
Okay. Great. That's C. How about now we mess with A? Go for it. Get it right this time. It's not the same, but it's similar. So this would be
Sine A. B over C.
okay. And then suspiciously, I'm also going to solve for. Don't give it to me. Equals. Do you see it? Both equations say. So I could now say it.
Get A times sine C equals C times.
Okay. Now comes the magic. Somebody, not me, decided to divide both sides by AC or CA. Oh, now I see why they divided by that, because look what happens.
Sine over. Oh,
The C's cancel, the A's cancel, and you literally get 2/3 of the law of sines. What are we missing? So we better now. It's got a line through it. Could we not have a line through it?
yeah, just erase that one and draw a different one.
Okay, so I'm going to erase that one and draw to side A, right? Do the same thing, just do that. There's my beauty so far, right? And then do the same process, but this time with angles and C. So I'm gonna do the same thing. So B is equal to, sine of B is equal to H over C, solve for H. Okay, now do the same thing for angle C. Solve for H. Do the same process. And then what was the magic? What was the magic that we did? Divide by CB or BC, and the C's cancels and the B's cancel, and you're left with that. And that's almost the law of sines. Anybody see it? Transitive property, right? If this equals C and this equals C, then this must equal that, or that must equal this, however you want to write it. So they both say sine C, so these two are equal to each other. So just tag it on there, and there's your law of sines. Well done, you proved it. All right, write that down. That's the law of sines that Elena remembered, and nobody else. Now that you see it, do you remember last year?
No.
You did this, Julia. It's on your test.
You showed me the test?
I can't run out of time. Yeah. Julia Bennett.
Oh.
I'm keeping it for a couple years just in case somebody says, wait, did you really teach your algebra 2 or are you lying?
That could be a forged name.
Well, it could be, but at least I have something. That'll hold up in the court of law. It's got your name on it. It's got your handwriting. All right, we
I
good?
don't remember.
All right. Remember I just did that for the acute triangle. You can also do it for the proof's in the book. It's done the same. All right. So law of sines says you got to have this. Unfortunately for us, there are flavors involved that no one ever talks about because it's hard, but I will be talking about it on Monday. All right. So you can use the law of sines as box B in yellow. You can use the law as long as you have one side and its opposite angle, or if you want to think about it as one angle and its opposite side. You have to have that. You cannot use the law of sine. If you don't have that information, then you better use law of cosine. Okay, so you're required to have that one a little bit. You got to have a side and the opposite angle, or angle opposite side. And then you need one other piece of information, either an angle or side. Any one will do. One of them makes your life easy. One of them makes your life challenging. That's Monday. So you always need to ask yourself this. Hey, do I have a side and an opposite angle? Yes. Do I have one other piece of information? Yes. Okay. You can use law of sines if you so choose. Tonight for homework, you will choose to do that. Monday tonight for homework, you will choose to use that. From then on, I would always encourage you to use law of cosines. The book, so I need an angle and its opposite. It doesn't have to be A, it can be B or C, but I must have an angle and an opposite side. You cannot use the law of sines if you don't have that. The other bit of information you need, I don't care whether it's a side or an angle, doesn't really make a difference. This comes in 3 flavors. It comes in friendly, most math teachers teach this, and it comes in ugly. Most math teachers don't teach that because it's challenging. So, turns out, law of sines, 3 scenarios. These are the 3 scenarios. Today we'll do these 2. Monday we'll do that one. All right, you got to be really careful because it is, it's a nightmare, right? I did not make that. Okay. First thing you should always ask yourself when you're asked to do law of sines, which one am I in? These 2, even though these are technically 2 flavors, they work one extra step for each for one of them, but it feels like you're doing the same process. This one does not feel like you're doing the same process. All right. So I'm always going to ask you, hey, is it ASS or SSA? That's going to be question number 1. Because if it is, then you're going to be doing the right process. If it's one of these 2, you'll figure it out yourself. It's pretty straightforward. So what do these three flavors actually mean? So this is an example of an ASA. An ASA means these are the fixed things that cannot be changed. I cannot change the two angles and the side. So what's in blue doesn't ever change, right? What could change is the length of what's in red. If I change the length of red, right, I still have an ASA. So I have two angles in the included side. And it turns out if this is the case you have, why this is a good one, then there's only one triangle that you could actually make. If I extend this one, right, any distance is allowed, right? I'm sorry, I did this one first. If I extend this one, any distance is allowed. The only triangle you can make is that one right there. Hey, make this any distance. You can't change this angle. Not allowed to change the blue. So the only angle or only triangle I make is that one. Well, that would be the same thing as if I extended this one. The only triangle you make was that one. The only triangle you could ever make with ASA is that one. There's only one triangle. That's why this is a nice, easy one. Okay. Same thing with AAS. Blue is what you can't change. I can't change the length of this. I can't change this angle. I can't change this angle right here. What I can change is this distance and this distance. But if you fix this distance right here, there's only one triangle you can make right there. That's it. If I try to shorten this side right here, well, technically it makes a triangle, but it's got to be right here. So I'm not allowed to make it that short. I'm not allowed to make it that long. The only triangle I can make is that one. Long story short, there's only one triangle that you can make with AAS. Kind of feel where this is going toward? The other one, the worst one, the problem child. Elaine, is that you as a kid?
Nope.
Okay. All right. This is the one that gives you problem right here. It says one angle, can't change this angle on the two sides. It's the one angle, side. Clearly I can get a triangle, right? 100%. I can make a triangle right there. Well, there it is. Okay. I'm not sure why I didn't put a distance on that one. But since I'm allowed to change this angle right here, I can open this up to any distance I want. Well, there's a distance that you can open this up that it doesn't matter how you draw this line, it ain't going to connect. Because remember, you can't change this angle. Blue is fixed. It has to be this angle. That doesn't even make a triangle. So with ASS, you can make a triangle. You can't make a triangle. And when it gets worse, hey, this angle is fixed. I can change this. Hey, did I make a triangle? That's this triangle. But I can move this so I could actually make another triangle. And ignore this. This triangle ain't the same as this triangle. So it's a nightmare scenario where if you have ASS, you can make one triangle, no triangle, or two triangles. That's why this is the nightmare one. And many math teachers choose just to give you any one of these as an example. It's like, well, I just ignore this. There's no problem, right? But we'll do this. Not today, but this will be Monday. Okay. So law of sines only works for ASA, AAS, or ASS, right? It doesn't work for three sides. If you have three sides and no angles, you can't use law of sines. You can use law of cosines. The problem with ASS is you can get no triangle, one triangle, or there's two triangles. You end up doing triple the work. And there's a different process to use law of sines. Once again, this is probably why most math teachers are like, it's okay. I'll just ignore that. It wasn't until I took calculus. The teacher reminded us, hey, law of sines only if it's ASS, remember you got to figure out whether you have none, one, or three. And I'm like, what? And I had to learn this. I mean, it's not that complicated, but I just know that, I'm not saying I had crummy math teachers, but I know why they chose that, because it adds extra complexity to the problem. It's not that bad, though. So today I'm just going to be using the nice, easy ones. And oh, by the way, you don't even care which flavor of this you have, you just do the process. This has a different procedure. Okay, so can you use law of sines? Law of sines requires you to have at least one angle and its opposite sides. Do I have one angle and an opposite side here? Yeah. Now, as long as you have one angle and an opposite side, you can use this, right? It comes in two flavors, right? Hey, do I have one angle and one opposite side here? I do. You still need one bit of extra information. That extra bit of information could be an angle, or it could be a side, and it doesn't matter, right? Both of these are either ASA or AAS, right? I'm sorry, this is the ASS. This is the one you gotta be super, super, super careful with. All right. So what do you really need? This is the only thing you need to truly remember for law of sines. One angle and its opposite side. They're going to have to give you the other. They're not going to just give you two pieces of information. Maybe they could say it's isosceles or an equilateral triangle. Then they're kind of hittingly giving you some information there. But they have to give you one angle and its opposite side. So if you have one angle and opposite side and one other bit of information, yay, and that you can use it. One angle, one opposite side, yay, I can use it. Okay. They're either going to give you an angle or side. Friendly, easy, not friendly. Okay. Be careful. So how does all this work? Do you remember this being challenging last year? She doesn't even remember doing it 4 months ago, right? It ain't that you would remember something that's challenging, right? The only one that's challenging is this one. Okay, so here we go. We're only going to do 1, 2, 3 examples. Yeah, no, 4 examples. All right, here we go. Hey, can I use law of sines? Because I have, but it has to be one angle and an opposite side. You don't have that, no law of sines. And then I just need one other bit of information. But I want you to get in the habit of always asking, once you say, yeah, I got an angle and opposite side. Cool, I could use law of sines. And I want you to take a careful look at what extra piece of information you're given. What extra piece of information am I given? I'm given an angle. I'm always going to ask myself as the first question, so I can use it, do I have an angle side side? I have an angle side. So it's not that. So when it is this, we have a different procedure. But when it's just the normal law of sines, then that's what we're going to do. Step number 1, identify your angle and your opposite side. So what's my angle on the opposite side? 40 and 4. I plug that in. Granted, this particular triangle does say A, B, C, but it could say any letters it wants. It doesn't really matter of what these letters say. This letter matches this. This letter matches this. That's the part that matters. I ignore the letters completely. This goes with this. So I'm going to make that as my first ratio. See what I did? I take the other bit of information, which in this case is 60. I don't really care whether it's B or C. It's one of them. That's going to go on the top, and what's going to go on the bottom is the opposite side. So I just look to the bottom, and whatever letter is there, I put it there. It just happens to be B. Okay? And then I just go to town on a little bit of algebra. What are we going to do? Yes.
You're recording this, right?
I'm recording this. Okay, yeah. Okay, so algebraically, what am I going to do? Yeah, you could. She said, let's go cross multiplication. No problem with that. I don't do it that way, but 100%. If that's how you like to do it, go for it. Can't have B on the bottom. So she says multiply through by the common denominator. What's the common denominator here? 4B. That's how the next slide I show you doing that, but I give you a nice friendly introduction to it first, which is, okay, if we don't want B on the bottom, multiply both sides by B. The B's cancel. But then the very next step, I gotta multiply by 4. So wouldn't it have been more efficient to multiply by the common denominator 4B? Yes. Would it have been equally efficient to cross multiply? Yes. It's going to be the same amount of steps. Whichever one you like, do that. Okay, now we're at this step. Now what do? And then you grab your calculator and make sure you are in degrees, and it's going to spit out an answer. I don't know what homework says. Typically, it's around the nearest 10th or something like that. Do you agree you could get to an answer here? It says nearest 100th. Okay. Okay, there. It is the nearest 100th. I don't think I continue to do that, but 5.39. Okay. Are we done? It says solve for the unknowns. We got to find side C and angle C. Okay, you're on. Which one is the easiest one to figure out? Why the angle? Because they gave us 2 of the angles inside of a triangle. Some of the interior angles of a triangle, at least on flat space, Euclidean space, is 180 degrees. So therefore add and subtract for 180. Tell me if I'm going too fast. Yay! Now you have options. You could go back to sine of A over A. We got B now. You could use sine of B over B, but I will say that B, we actually did a little bit of rounding, so I would recommend don't do that. Go back to sine A because we have exact values. So we go back to, we're trying to solve for C now, little c, the side C. So I'm going to go back to sine 40 over 4 because those are exact values. We now know that angle C is 80 degrees. So sine of 80 over C, and Julia said the most efficient way is to multiply by the, what is the common denominator here? Lucy said you could also cross multiply. You would get the same thing, right? One step is going to get us to this. Cross multiplying will also get us to this as well too. Choose whichever one you want. We still have to do the last step, which is divide by 40, plug that into your calculator. You would agree that we would get an answer. As long as you are in. If you mess this up and you're in radians, it'll take a couple problems before you get to, I got 6.13. So I now know what little b, little c, and big C is. Yay, I solved for the unknowns. And this is a typical math class. This is what they show you, and everybody says, law of sines is fun. I like this one. And you get the law of cosines, you're like, oh, it's got so much more. So I like law of sines. It's because they never make you do the SSA one. Coming on Monday. All right. I got 3 more examples. It's no more for the easy ones. That's it. It's not that complicated. It's straightforward, right? Hey, here's an obtuse one. Nothing changes because it's obtuse. It's the same process. I will say visibly or visually, the obtuse one, sometimes it's hard to, hey, match up an angle with a side. Just be careful, right? You notice how close C is to the 5 and how far away that this angle right here, which isn't even labeled, right? Which would be angle, which is angle B, because it's opposite side B, right? This one would be A, because it's opposite little a, right? So they don't label it in this particular case, but you can figure out the labels just by looking at what they gave you. Okay, you're on. First off, is it SSA? Because if it is SSA, we got to use a different technique. Well, how do you know it's not SSA? I just look, are there 2 numbers? I look, are there 2 numbers for sides? As long as you have 1 number for a side, it's not going to be SSA. If I just have 1 number, it's got to be AAS, right? AAS, right? Or this one's ASA. Sorry. ASA works the same as AAS, same process. So is it that? The answer was no. So give me the angle and the opposite side. Oh, wait, there isn't one. However, for this one, this is your ASA one, you can calculate the other angle because they give you 2 of the angles. So Julia says C is, what'd you say? 130 because you
add the 2 angles.
Added the 2 and subtract 180. Okay, so we got 130. Yay! Now we can go to town. So I'm not using angle A, right? Because angle A is right here. That's, oh, I can use angle A, can't I? But I don't know the distance of A. So I can't use it. I got to use the C's. So angle C is 130 and side C is 5. So what I'm really using is, well, sine C over C, but it's kind of immaterial, right? Letters are just letters. I'm using the correct ratio. Okay, what do you want to solve for? A little b or a little a? I don't remember which one I'm solving for. I think I chose, I don't know what I chose. I chose A. All right, thank you for choosing A. So if I'm going to choose to solve for little a, I'm going to write sine of 35 over A. Okay? You could have done B as well. It doesn't make a difference. And there's a pattern. He's doing cross multiplication, I think, right?
5 sine 35 over 130.
Okay. Are you trying to do all the steps in one shot? Just be careful. You could easily screw that up and put them in the wrong order. People aren't gonna screw up cross multiplication or canceling, but if you try to do this and the next step, it's easy to see now, right? We good with how we get to an answer here? Okay, so 3.74. Which only leaves to solve for side B. Tell me if I'm going too fast. So to get B, I'm going to go back to the side C and angle C again. So sine of 130 over 5. Now I'm solving for B this time. So sine of 15 over B. Multiply both sides by common denominator or cross multiply, your choice. Divide both sides by sine 130. Grab my calculator, away I go, and I found out that it's 1.69. I will say this. Because there's a lot of numbers there, and the process is so easy, it leads you in this false sense of security that, oh, I'm going to get this one right. I would always look at your answers. Hey, I got C of being 130. That makes sense. C is obtuse. I got a 3.74 for A. Side A is the second longest side, right? The longest side was 5, so A was smaller than 5, and B better be smallest, and it is. I mean, I would always do a common sense check because calculator's not your friend, and it's easy to mess up numbers. We think we got the idea? Okay. Once again, they don't have to use ABC. Here's PQR. Can we use law of sines for this one? Do we have an angle on an opposite side? Or could we figure out the angle on the opposite side? Yeah, we do. 45 and 15. And then one bit of information I'm always going to ask, is it SSA first? SSA is going to be the one where I have two sides. I only got one side, so life is good. Law of sines is fun and friendly and easy. Okay. So what's the setup here? Sine 45 over 15, and then you pick which side you want to solve for. Did I go alphabetical? I did. So I'm going to solve for P next.
I would say go for Q,
Why?
because you can figure out angle Q, so then you would only be left with.
You still have to
Oh
find
wait,
P.
yeah.
So it wouldn't make a difference. Nice try. All right, so sine of 71 over P. Landon, give me the setup. For the one I'm doing.
No.
You, Landon.
Sine 45 over 15 equals sine 71 over P
Good reading.
equals sine of hold on, give me. With 131 minus 71 be 6.
What are you doing?
Subtracting. I'm getting the other angle. This one.
We don't need it. We need to solve that.
Oh, sine 45 in parentheses P equals sine 71 and
Solve for P real quick.
minus or 5 both sides by sine.
And you would get an answer. All right. Everybody can handle the rest. I'm going to show you one last thing and then have a great weekend, right? No, we're not going to do this one. Tonight for homework, or over the weekend, they're also going to give you, ready for this? We've just done ones that look like this, but couldn't they also give you this with just words?
Stop.
So yes. So guess what you should do first? Draw the triangle, plug in the information, and then it turns into it just one extra step.
That's not that bad.
It's not that bad. No.
It's like a paragraph, right?
No. It's gonna look like this.
Okay.
Can I see that test?
Do you still not believe in you?
No, like I'm just wanting to see what it is.
Oh, much after the period.
Familiar? Let me. This is your handwriting.
I thought you were saying. Yeah, Julia, that's yours right there. Sound like lost.
Boy.
What do you mean?
I'm just, you're the one that,
I was asking you for.
I did not record our conversations when I said, are you good on law of sines and cosines, yada, yada, yada. You go, yeah, I'm good.
Yeah, I'm like.
Avery, do you remember doing this last year? Okay, most people will remember it.